I'm Raph Levien. I'm on the Android UI Toolkit team, and I'm going to talk to you today about Android textual layout. And I hope you'll find this an interesting talk, and I hope you brought lots of questions as well. And I'm happy to address those after the session and also at office hours this afternoon. So I'm going to talk about it's kind of a grab bag of a bunch of different topics around text and typography on Android. I'm going to talk about some of the challenges and opportunities, just a little bit of an introduction to material design, which I'm sure everybody here is quite familiar with. Then I'm going to go into some of the details about the Roboto II and Noto fonts, and especially the kind of more recent changes around these to better support international typography. A huge amount of the work that we do on the Android UI Toolkit team is supporting all of the languages of the world, or most of them. Then I'm going to go into some of the really, I think, exciting newer features around OpenType typography control and high-quality paragraph layout, which rolled out in Lollipop and Marshmallow. So what are some of the challenges and opportunities? I mean, I come from a print background. Mobile, doing typography on mobile is extremely different than doing typography on print. There are some things in common, but there are some things that are really different. You have to be very focused on the performance, of the text stack, because you've got only so much battery and only so much RAM. But you really do have very powerful compute resources. You've got multi-core, multi-gigahertz processes in there. So if you want to do sophisticated, advanced typography, you do have the compute power to do that. 60 frames a second is absolutely a requirement, and this is, again, both a challenge and an opportunity that you can do these really rich animations and transitions and do this kind of interactive motion typography that really is completely impossible in a print background, but you have to make everything fit in that 16 millisecond budget. You've got a very small screen, and this has some interesting challenges in how you create your layouts, how you do the paragraph layout. But a flip side, again, is that on modern devices, you have this very high resolution. Then, as I mentioned, we have this requirement to support all of the languages of the world, all of the scripts of the world, but we have a lot of really good resources, both in fonts and typography control of how you do that. And then, I'm going to talk about some of the line-breaking improvements, some of the paragraph layout improvements in Marshmallow, and those were really motivated by a need to get this working in very small screens like watch faces. So I'm going to just kind of introduce this concept of, like the advance of display technology. This was the first mobile device I ever had when I was 12 years old. And I mean, as you can see, it's got a lot of the elements of a modern mobile device. It even has a really nice big keyboard. But the display technology in this generation of technology is kind of the bare minimum that you need to get text displayed at all. And I think that evolution, kind of carried that there was a very primitive approach to just get the letters drawn on the screen and not really think about typography. Another good thing about this screenshot is you get some sense of like the difference in computing power available today as, back then. So, before I worked on Android, I was working on Google web fonts, Google Fonts. And the upper left corner is kind of your classic laptop or desktop screen. And this really ruled what we did, that you have a very small number of pixels to represent the text. And you have a lot of constraints in how the letter forms map into those pixels. And that also includes like the spacing. You see kind of very poor, like the A and P are crunched up together and the P and O are separated because you only have so many pixels and so much precision. But as you go into more modern display technology, you have so many more pixels. And so on the upper right, you have a 4K monitor, which is starting to replace laptops. And on the lower left, this isn't even the most recent device. This is a 2-year-old device, and it has 468 ppi. And you probably can't even see the pixels here. And then comparing that to, for example, an inkjet printer, you actually have on these mobile devices, you have a much higher precision, higher quality representation of the shapes of the letter forms and the spaces between them. So it really enables typography. And all four of these screenshots or captures are of the same 12-point Times Roman. And so this is what we have to work with today. This is our lead device, the Nexus 6P. It's an amazing device, and it has an amazing screen to match the overall device. It's at 515 ppi. One of the ways I think about screen resolution is, when Star Trek, when they were doing the Star Trek TV show, they had like a book that had all of the specifications for all of the technology, like how many terajoules were in a phaser pulse. And one of the specifications is what is the resolution of these little devices that people are carrying around? And the answer is 400 dpi. So, we've blown way past Star Trek. So, I mean, as I say, everybody here knows about material design. This will just touch on it, that, the UX team, it started really about 2 years ago, that they were looking at these kind of more powerful devices, higher quality display technologies, and they were really thinking, how if we were redesigning this from scratch, if we really could do anything, what would we do? And the result of that exploration really synthesized into a set of guidelines, into a coherent design language that incorporates many different elements. It incorporates colors, it incorporates the material metaphors with paper and kind of a three-dimensional effect. And it also incorporates typography. And so, one of the sections in the material design spec I really recommend, it's very, it has a lot of good information and a lot of good guidance about how to do typography within material design. And of course, another part of that is a much greater expanded palette of different weights and of different sizes, and how you kind of use the weight and size instead of having just one size of text, one weight. You use this to indicate the structure of your app, the structure of the information in your app. So the cornerstone of typography in material design is the Roboto II typeface. And so this was an update that happened in Lollipop. And, it was pretty subtle. A lot of people probably didn't even notice it. But there was actually a lot going on in this update. So one of the things is the expanded Unicode coverage. It actually increased by a factor of 3. And we have full support for Unicode 8 for Latin, Greek, and Cyrillic scripts. And that covers a lot of the languages in the world that, that are maybe less familiar to us. Like the African languages use a lot of kind of unusual Latin characters. We also expanded the weights and styles that we ship on the device. So we're doing thin, light, regular, medium, bold, and black. So there's a tremendous palette of the visual effects that you can get. And all of those include true italics. And we also have a family of condensed, which is better for better information density, and also can give you some contrast, two different styles that you can work with in your app. In addition, the Roboto II font is completely open source, and that includes not just the final TrueType font files, but the entire build chain. So you can go in there and customize it and play with it, and send us pull requests. And we really treat almost everything we do in a very open source manner. So the design updated as well. And this is just a little bit of a kind of a before and after, and you can see it's a little subtle, but like there's kind of a stiff sides to some of the characters, like a capital O, and that has become a more refined, gentle curve. Some of the shapes were maybe a little bit unusual, like the K's and the capital R, and those have become kind of more simplified and more streamlined. And we also went from a square dot on the I's and J's to a round dot. So it's just it's an evolution. It's a more refined form of the original kind of design that's very central to Android, and very central, of course, to material design. So I talked about the global reach of Android. We talk about a lot about the next billion users, and they're like we heard in the previous talk about how do you reach them through the Play Store console, but there's also a lot that you have to do with the presentation of text and language in these devices. So again, Roboto II dramatically increases the Unicode coverage, And you can see this is just a sample. This is just one of the pages of kind of additional extended Latin characters. And another thing I'll point out, just for this slide, like if you look kind of near the middle towards the left-hand side, you see some O's with some doubly stacked accents. And that's a very common pattern in a lot of languages, but not European languages that we're used to. So you see it in Vietnamese and some of these other languages. So you really, when you're designing your apps, when you're testing your apps, you really need to be careful to test them in some of these other languages to make sure that you've got enough vertical space. This is kind of one of the real key takeaways, that if you just design in English, you've got these letters, they don't have anything going on above, they don't have anything going on below, but that is not the experience of millions, hundreds of millions of people around the world. So in addition to Latin, Greek, and Cyrillic, there's this huge diversity of other languages. And in fact, this is the list of scripts, not even languages. There's many scripts that support multiple languages. These are the Noto scripts that we're supporting in Marshmallow. So it really is huge expansion compared with previous versions of Android. And it really covers a very large fraction of the languages that are spoken in the world. And so here are 3 scripts that I just kind of picked out as representative. I find these just really beautiful, and you can see, kind of a tension between classical forms, but also trying to make them consistent with the kind of clean, Roboto design. And so I think these 3 are either new in either Marshmallow or Lollipop. So then, in addition to this kind of large set of scripts, CJK, Chinese, Japanese, and Korean represent a very large fraction of the users of Android. A lot of the users in the world. And so in Lollipop, we launched NotoCJK, which is a joint project with Adobe. So it's also out there. They released it as Source Han Sans, and that's also an open source project. And it has a tracker. It's very active. People find issues, and it's being revised. And in addition to just the fonts, that project also kind of brought with it a high-quality renderer for something called CFF, Compact Font Format. And this is based on the Adobe code, but it's now been open sourced as part of FreeType. So you can go look at the code, use that in your own projects as well. So NotoCJK is a very ambitious project that it really is designed to be a comprehensive support font to support all of CJK. And that includes the different local forms. So there's a difference between simplified and traditional Chinese. Those are different from Japanese, and then there are some glyphs that appear different in Korean. And it's very important to these users to see the correct form in their language. If you see it wrong, it really is a polish problem. So NotoCJK has a unified design. There's like a consistent, there's some releases that we've done where the Chinese and Japanese really don't look like they're part of the same family of fonts. And in NotoCJK, we really have a unified design, but we have the different variants in the different regions. So no discussion of text is complete today without talking about emoji. And we really treat emoji as a type of text. So an app doesn't have to do anything special. An app doesn't have to say, show me some color images here or something like that. You just represent text, and you ask for the text to be drawn or in a text view or edited, and it just automatically shows up using this color font technology, which is now standardized in OpenType 1.7. So, and there are actually many tools, many font editors actually will create fonts in this emoji form. So if you want to, or I should say in a color font form, whether it's used for emoji or not is really up to you. And you can incorporate these custom fonts in your app and get color representation of either emoji or text just by dropping in the font. This also supports flags and keycaps. It's a more expanded set of emoji. And one of the new APIs, I should say this is a Marshmallow API, that in a lot of apps, you want to know what emoji are present because you want to make a decision. Do you present this as a, as a palette for users to choose? And this has always been a problem because, different phones will have different emoji sets. And, as we're upgrading, it's hard to know, is this emoji present or not? Or does this flag exist in the case of the flag emoji? And so we've got this new API that will tell you. It's very fast. And we really recommend, we really want you to be using hasglyph so you know what emoji are on your device, what you can use. So then I want to talk about some of the typography features. We've really been expanding this. My goal certainly is to make Android typography match what you can do on the web and match what you can do not just in print, but like really high quality print. And so I'll walk you through some of the things that we do here. I'll just go through this list and then I'll show some examples that we have kerning and ligatures. We've actually had those since I think Jelly Bean MR2, but now there's more control. So if you want to turn those on and off, there's fine-grained control to do that. We have this font feature settings attribute where you really can go in and control the OpenType features. I'll give you several examples of that. And that's using a CSS-compatible syntax. So we want to make this stuff so, if your designers are, used to controlling typography on the web, we want to make that kind of impedance mismatch as smooth as possible. So, so you can just take that knowledge and apply it to Android apps. And then this is a little bit more technical thing, but we use OpenType integrally to give you these localized forms that there are many languages, certainly not just the Chinese, Japanese, and Korean, where there's going to be subtle differences, the same basic script, but differences in the way it's presented. And we use OpenType to control that. And I'll talk a little bit also about what you want to do in your app to make that work perfectly. So kerning and ligatures. So the FI ligature is a little controversial in Roboto. Not everybody loves this, but it is definitely a sign of kind of more sophisticated typography, that you don't just put the letters, that in some cases you have these combinations and you have a specifically drawn glyph that represents more than one letter. And this is certainly, this exists in Roboto, and it's a very important part, like especially in serif fonts. You really need those ligatures for the font to display correctly. So if, again, as you're using custom fonts in your app, you want those ligatures. And the same is true for kerning. You almost never want to turn this off. The only time you might want to turn it off is if you've got some kind of technical alignment where things need to have the consistent width, no matter what the characters are. But in any case, as of M, with the font feature setting attribute, you can control these. These are actually implemented as OpenType features. And as with any OpenType feature, you can turn it on or off with font feature settings. And that's actually a Lollipop Plus API. Another kind of great hidden feature is the use of proportional and old style numbers. And these are really important for kind of a more refined, sophisticated typography, that the default numbers are basically the same size as capitals, and they're all the same width. And being the same width is really important if you've got some kind of animated display. You don't want it to be juddering back and forth, or if you've got kind of a tabular presentation of numbers like a spreadsheet. But it's not always the prettiest display. And if you're doing like running text, if you're doing paragraphs of text, then proportional is maybe a more subtle change where you just give the one a little bit narrower so you don't have all this space around it. And then if you're really trying to do something that looks more like a book, something that looks more like traditional typography, then you've got these old style figures. And those are in Roboto II. Those are present in the font, and you use the Android font feature settings to select pnum, proportional numbers, or onum, old style figures. And again, highly recommended if you're bringing custom fonts into your app, that you have the complete access to all of the OpenType features in those fonts. And this is, again, an L+ feature. Another feature that I think is really powerful tool for bringing kind of more sophisticated design to apps is control over letter spacing. So there's a default letter spacing. It's really tuned for legibility. People are getting information on their phone. They need to be able to read it quickly. And that's what the default letter spacing is tuned for. But if you've got something that's kind of larger, more of a branding and less of a kind of a functional element, then spacing it a little tighter might kind of highlight that. And then you can also use wide spacing as maybe a form of emphasis or just bringing a little bit more breadth to your design. So you're no longer stuck with just the default spacing that's set in your font. And again, that's an L+ feature. So in Marshmallow, this is really one of the things I'm most excited about, that we really stepped up the paragraph layout. And the old algorithm kind of used, you fill up a line, and then once you get to the point where the line is full, then you just break at the word boundary and you keep going. But in Marshmallow, we have this high quality paragraph layout mode, and it incorporates a couple of different elements. It incorporates automatic hyphenation, and it also incorporates this concept of whole paragraph optimization. So it kind of moves pieces around to get like a best score, to get there's kind of a score that tells you what is the quality of this layout, and it's really trying to optimize that across the entire paragraph. Both of these algorithms are based on TeX, which is a print typography package that has a very long history, and high-end print publishing tools use this same approach. But the parameters, like when do you use hyphens? Hyphens are a little bit weird. People are not used to seeing them on a mobile device. There's some contexts where they make a lot of sense, like if you're displaying an ebook, for example, and there's some where maybe it makes a little less sense, like UI strings or maybe chat messages. People are not used to seeing hyphens there. So we tuned the parameters. It's heuristics, and we kind of chose these so that a couple of things that people were noticing, that if you hyphenate and you break a partial word onto the last line, that is really weird. That's something that people have a negative reaction to. So there's a parameter in the tuning that kind of doesn't do that very often. But on the other hand, one of the reasons why you want to do this hyphenation and want to do this high quality paragraph layout is you want better information density. This is especially important when you have very narrow settings, and especially true on very small screens like watch faces, that if you break a word and you leave a huge amount of empty space, that's waste. That's an opportunity that you could have used that space to present information. So we really look at this question of, would hyphenation bring you n lines down to n-1 by doing the hyphenation? And in that case, we say, yes, you do want that. You don't want to waste that space. You want more information density, and that increases the chance that you'll get a hyphen on there. So this is kind of a different tuning than you would expect for something like print typography, which is where there's kind of the most tradition of doing hyphenation. So one of the other things we looked at is this question, do we want to have like a opt-in where your app says, yes, I want high quality mode, but maybe it's considered expensive, it's too slow to run, or we don't want to always have it. But we tried turning it on across the entire system as a default, and we really liked what we saw. I mean, that you want a higher quality presentation of paragraphs. Of course, if it is not right for your app, then please turn it off or control the tuning parameters. But we also had to do a lot of work on the performance. So it's doing a lot more work. There's a lot more sophistication that's going on in there. But overall, the amount of time that it spends drawing text is about the same as Lollipop. There's some use cases that are faster. There's some where like maybe some of the benchmarks where we've gone backwards. But we've really tried to make that usable for everybody. And so here's a kind of a demo of the kind of profound difference that you can see, that you really see on the left-hand side, which is the pre-M paragraph layout. And you can still get to this by setting break strategy equals simple in your XML. But you see these huge gaps where, like the word conversation, it doesn't fit, so okay, it just goes to the next line. And with the high quality layout, it says, okay, we can hyphenate that, and we can actually get this block of text that's very, clean. Like it really looks much more like a book and less like kind of computer text display. And on the right-hand side, you can see it's actually pretty eager to use hyphens, and that's a control. There's a default, which is a little less eager. It uses hyphens when they really improve the density, when you really improve those huge gaps. And then there's this setting of full, hyphenation frequency equals full, which is really appropriate if you are displaying paragraphs of text, if you've got an app like an ebook reader where you're really displaying paragraphs, then we recommend using full instead of the default. And if you want to turn hyphenation off, you can actually you can mix and match. You can have a high quality strategy in terms of the optimization of where the line breaks go, but just no hyphens, and that's another option. In the same kind of increased control, enhanced control over line breaking, we were looking at this particular problem, a very common pattern for UI strings. You've got a string that just doesn't quite fit into the space, into the width of the set. And then you get this word, UI strings are often very short, so this happens like quite a lot where you just have one line, but you have like one or maybe two words that go to the second line, and it just doesn't look nice. It's not a very pleasing visual presentation of this text. So you can select break strategy equals balanced, and that tries to line it up so that all of the lines are the same, are roughly the same length. In a traditional paragraph, you try and get all of the lines except for the last the same length, but balance really just tweaks that one thing and says, just make this whole thing line up. This is based, again, for designers who are familiar with web technology, this is based on Adobe's proposal for text wrap balance. That hasn't become a standard. I don't think it's widely shipping yet. But again, we're trying to make the design of typography on Android similar to the design of typography for the web. So I wanted to also, I mentioned when I was talking about the different languages and the kind of different things that we do to change the way we present text, that this is really one of the most important things that apps can do, is to get the locale of the text that the app is displaying correct. Because if it's wrong, things will you'll still get the text displayed, but things will be degraded. They won't be as nice, they won't be as polished as if you set that locale correctly. So there's 3 different ways that locale flows into text in Android framework text. There's the settings, which are system-wide, which control a default locale. And of course, this is the default. This is what happens if you don't do anything. And you hope it's right, but unfortunately, there are a bunch of cases, mostly when you have multilingual users. In America, there aren't any, but in the rest of the world, there's a lot of people that speak more than one language. And so the language that they're viewing the app in, the language that they're interacting, they're maybe looking at user content, might not match the system setting app. So we have a set text locale API, which you can use on a text view. And if you have metadata, if your server knows the language that text is, then we strongly recommend that you set text locale on the text view that displays that text so that the locale is correctly identified. And then this may be a little bit more specialized, like for something like a translate app, where you may have a single string that contains multiple languages. It might say the translation of this word into this other language is some other word, and you might have a language that's just a span. And for that, we've got a locale span, and you can set that on just the text in your app that represents that span. So what does the locale do? I mean, like I've said, it's important to set it, but what happens? Like, how does that actually control the way text is displayed? And before Jelly Bean, there was no difference at all. Like, text just displayed. But in Marshmallow, there's 4 different ways that locale affects the presentation of text. It changes the font that's chosen, And that's especially important for distinguishing between traditional and simplified Chinese, as well as Japanese and Korean. Those are different fonts that are unified. It affects this local OpenType feature lookup so that like there are differences in Devanagari script between Hindi and Marathi, and it makes sure that you get the correct forms of those letters, things like Persian numerals and so on, or well, Persian numerals are complicated, but the point is that if you know the language, then setting it will get the correct lookups to happen on the font. The locale also affects line breaking. There's some languages where deciding where the boundaries are between words, where you can break the line, is actually kind of a complex question. Thai is the most common, certainly, that you'll see, where there's no spaces. And so you really, in the case of Thai, you need a dictionary. You need to say, this is the word so that I know where the boundaries of the words are. And that is completely reliant on knowing what the language is. If you just put Thai text through, but don't identify that the language is Thai, then it gets confused and you get line breaks in potentially very bad places that don't line up with words at all. And then, of course, lastly, now that we have automatic hyphenation, that knowing which dictionary of patterns to use depends on the language. And this is, like most of the things that I just talked about, are kind of more exotic languages to this audience, but automatic hyphenation is important between, for example, Norwegian and English. They're both in the same script, but if you use the wrong patterns, you'll get weird hyphens. And then there's there's this, how do you know what the language is? And fortunately, there is an open source library. I mean, this is actually mostly developed by Google, but it's out there, the Compact Language Detector library, which is now in its second version. It's open source, and it's designed to be very performant, very fast. It's not a huge dependency to take on. So if you've got an app where you're displaying messages and you really don't have the metadata, you don't know where it came from, what that language is, but you want to ensure that it's displayed with the highest quality, and of course that metadata can be really useful for lots of other things, then we really do recommend this compact language detector, and that'll you pipe the output of that into set text locale, and that really improves the quality of your display. So that's kind of all of the prepared topics that I had. I want to open it up to questions. I'm happy to answer any questions you have. And please wait for the mic to come to you.
Hello. On the topic of custom fonts, so you can achieve custom fonts via on simple views such as text view, but it's pretty difficult to do for framework UI classes such as navigation view or toolbar. Is there a recommended way by the frameworks team to achieve custom fonts globally within your app?
Yeah, that's a good question. I don't think we have a mechanism for applying a font globally across the app. So unfortunately, I think that is something that you have to do with code. But that's something that we're interested in looking at, making easier.
Hi. I get a lot of requests from design for situations where they want the text to be exactly this size, possibly because it's aligning with an image or something like that. What is your recommendation for what I'd ideally like to do is have the text shrink down if it's in, say, a language that has more text there?
Yeah.
What is your recommendation for that?
That's a very common request, and we do not have support in the framework for that yet. It is something that we are really looking at. There are a number of open source libraries. One of the reasons that we haven't implemented something like that, I looked at it, and one of the problems that you get into is that you get kind of how do you specify what that behavior should be? So you just specified kind of one point in there where you want it to be exactly that size. But there's a lot of other use cases where people are trying to, because you're trying to line it up basically with other graphic elements. There's a lot of other cases where people are just mostly concerned about making it fit. So they want kind of different logic. They want something that says, make it a standard size, make it 14 SP, unless it doesn't fit, and then we want to have, whoops, excuse me, and then we want to have it shrink down to some other size, but we don't want to have it shrink down to, below like 8 because then it becomes illegible. So you get these cases where like specifying how you want that behavior to scale is kind of complicated, and that's kind of, if and when we do implement something like that in the framework, we really need to make sure that we cover the range of behavior in a way that makes sense. Until then, I'm not going to recommend any specific open source library, but there's a bunch of them out there, and it's likely that there's something that just subclasses, text view and overlays that behavior. That it's likely that there's something that will fit what you need.
Early on, I saw a mention for CSS styles being applied to text. Is that something that's done through styles, or is it through the use of HTML text? Okay,
so I'm sorry if that was misleading, that it's not CSS styles in general that we're applying to text, that there are specific attributes, there's specific parameters, and that and in that particular slide I was talking about font feature settings, and it's like the syntax, because specifying all these OpenType features is kind of a complex thing. It's not just like a number or something like that. And so we adapted the syntax from CSS. It is compatible with CSS, so if you have that particular feature, other features that we've got like letter spacing, the name of the feature, the meaning of the feature, we're trying to make it consistent with CSS, but we haven't like implemented a web browser in Android framework, text. You can use WebView, but that's, there is not like a generic CSS translator. It's just these specific features that are low impedance or compatible with CSS.
What is the performance cost of the high-quality text layout strategy with hyphenation? For example, if you want to actually change the text view contents, so what is that going to cost you at layout time?
Well, measuring text performance is really complex. I mean, the order of magnitude is that it's about the same as simple text in Lollipop. So, it's doing more work, but we actually took a wrench to it and did a lot of optimizations to make it go faster. There's going to be some specific cases that are going to be a little slower. There's other cases, like if you're editing a very large buffer, that it's going to be a lot faster, because we really did a lot of performance improvement in that area. So ultimately, if you're really concerned about performance, like if you've profiled your app and you've said, oh my God, I'm spending all of this time doing the layout of the high quality layout, and if you've decided that the visual improvement of that is not worth it in your app, then by all means, set simple. We have not come across, I can't really think of any apps that I know of, either first party or third party, where people have felt a need to do that, but it's certainly an option. And we will continue to improve the performance. This is a very important area for us. It's got to not jank.
Also, will there be a support library for this?
No, unfortunately, a lot of the stuff that happens in framework text is at such a low level that you can't really fill it in with a support library.
Hi. I know better than to ask you what you guys are going to do in the future, but I wanted to ask a little about static layout and the new method that lets you set custom margins per line.
Yes.
So I know it's not ready to do full wrapping around a path, which is what I imagined when I first heard about it, but I am wondering, what were you guys imagining when you added it? Is it just the circular watch face, or is there something else cool I could do about it? I don't know yet.
Oh, great. No, and that's a slide that almost happened in this talk, and I wanted to keep it simple because I wanted to, talk about things that, would be for most developers. So certainly the circular watch face. So maybe I should just explain that there's layers of the text stack, where text view is the one that most of you interact with. But underneath text view is static layout, and static layout does a lot of the things around line breaking and paragraph layout. And then below that is like draw text and the kind of very low level APIs. And in static layout, we have a new method that lets you kind of adjust the shape by controlling indents on the paragraph. And so yes, the watch face was absolutely a motivation for that. We are seeing other applications. People are adopting it in cases where people are doing custom views rather than just relying on text view. One of the really nice ones is when you just get to flow around an image, where you're basically doing something like a web style float. It is possible to do your own, to kind of roll your own if you've got a path, to figure out based on the knowledge of the line heights and stuff like that, to figure out what the indents are. I think you'll see this continue to evolve. Clearly there's, it makes sense to do a higher level feature that has, kind of easier to use, is not so low level, but unfortunately it is not there yet. Any other questions? All right, well, thank you so much for coming.